Say we were starting 6.2 exponential functions. The first section only dealt with growth and decay, and it dealt with the growth formula, the a times 1 plus r to the t power. Yeah. Exponential function. F of x equals b of x, or b to the x. B is the base, and it is always going to be a positive real number. Well, it doesn't have to be, but for right now. X is the exponent and is any real number. We're going to graph f of x equals 2 to the x. We're just going to pick some points. Let's go -2, -1, 0, 1, 2. Two to the negative second power. The first one. 2 to the negative second actually means 1 over 2 squared, which is 1/4. If it's negative exponent, it belongs on the opposite side. If it's on the top, it belongs on the bottom. Just square it. 2 to the negative first means 1 over 2 to the first, which is just 1/2. 2 to the zeros, 1. Anything to the 0 power is 1. 2 to the first is 2. 2 squared is 4. Now, just so you see, if I did 3. 2 to the third is 8. Yeah, 2 to the negative third would be 1/8. That's pretty much what it is. It's the reciprocals of the positives. That's what they are. When I graph this for -2, how much do I go up? 1/4. So it's just above the 0. At -1, it's in between 0 and 1. At 0, it's 1. At 1, it's 2. At 2, it's 4. And then 3 is 8. What's happening? They're going.
What now? What you talking about when you had doing the book the other day? When you talking about like the quadratic, the linear,
Exponential, yeah. This is exponential. It gets really, really, really small here. Will it ever hit 0? It will never hit 0 because if I had 2 to the, give me a really, really, really big negative number. -54,000. It says 0, but there's a reason why on my calculator. Huh. No.
Right.
You shouldn't. It's not 0.
You want me to do it?
You know what? You're going to get the same thing. It should give it to you in scientific. All right. Nope. It's actually too small for the calculator to figure it out. That's why. Let's try the 54. There we go. E to the negative. It's really, 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 really small. I picked too large of a number. I thought the calculator would at least put like e to the negative 100,000. It is. No. That's what it doesn't reach 0. It gets really, really close, but it never does hit 0. Times 10 to the negative 17th. So you have to move it 17 decimal places to the left. How many decimal places do you want? I want you to graph this one and see what happens. All right, when you make your table, x, f of x, negative 3, negative 2, negative 1, 0, 1, 2, 3. What happens for 1/2 to the negative third? It becomes 8. It's the flip of it. So, right, and this would be 4, 2, 1, 1/2, 1/4, 1/8. What it was for this one. Because what you really have is 1/2 to the negative third. The negative third says it belongs on the top, so it's 2 to the third, which is 8. When I graph this one, 1, 2, 3, 8. 2, 4. 1, 2, 1.
India Love, report to the library.
So this looks.
India Love, report to the library at this time.
What can you tell me?
It's the opposite of the other one.
So what do you know?
When it's a half, it decreases, and when it's a whole number, it goes up.
Okay. When it's less than 1, it's a decreasing. So if you have a fraction less than 1, it is decreasing. If I have a number greater than 1, it is an increasing exponential. Now, when I said about the whole negative aspect, now I can graph this. 2 to the x. That's the first one. I graph. That's what it shows. I can change it so it's the 1/2. And when I graph, there's my graph. Now I can also go second graph, and there's my table. The only thing about the table, it gives you everything as a decimal. Now originally I said it had to be positive, right? If it's negative, and I hit graph, nothing showed up. Second graph. What do you notice? It's, look at my numbers. It goes positive, negative, positive, negative, positive, negative. It's not exponential. For exponential, for these problems, it has to be positive. Yeah. Right. It would be, all right, at 0 it's 1, then it goes -2, then it goes to positive, then it'd be negative. It's going to be like up and down, up and down. It's not exponentials. Exponentials have to look like this. So it always has to be a whole number, whether it be greater than 1 or less than 1. Now, for growth and decay, we already talked about this, right? Before, we already know that if the inside, remember we had a equals p times 1 plus r to the t. This right here, if it was greater than 1, meaning growth, if it was less than 1, that's when we had decay, and it was always 100 minus that percent. No, it's just rephrasing what we did before. It's tying the two together. If f of x equals 2x, we're going to graph 3 times that and 1/2 times the negative of that. Yeah, we just did the top one. The top one is our first graph. I want you to look at what happens if I multiply it by 3 or I cut it in half and change the sign. Yeah, you can use graph paper. All right, going over this. All right, for the first graph, here's the original one. The original one was 2 to the x. There's the graph. Now, if I take this and do 3 times 2 to the x, what happens? What happened to your numbers? It tripled the numbers. So I'll look at the graph. What happens to my graph? It's bigger, faster. It's 3 times bigger. If I look at my...
Does that mean it gets bigger 3 times faster?
Right. So originally at -3, you had 1/8. Now it's 3/8. At -2, it's 1/4. Now it's 3/4. At -1, it was 1/2. Now it's 3/2. At 0, it's 1, but now it's 3. It's 3 times faster. Yeah, you can make a table just by doing this, too.
Now, how did you get there?
Second graph. My thing is wrong. Now the next, for this here, this is 1/2. Actually, that's what I'm going to do. 1/2 times. Now this one's different in the calculator. I'm not going to put, I can put 2 to the -x.
Would that be the same thing as -2?
Two different things. I showed you what happens if I put the negative on the 2. This tells me everywhere I see an x, I need to put a -x. If I graph that, there's the original. There's the second one. Why is it this way? Because of the half. It made it go the other way. Now if I...
Oh, yeah, because half is less than 1 decrease.
Right.
Duh.
All right, let me do the chart. I'll do it by hand. You had your original one. -3, -2, -1, 0, 1, 2, 3. This was 1/8, 1/4, 1/2, 1, 2, 4, 8. That's the original one. Okay? For this, I'm just showing you. For the second one, -3, -2, -1, 0, 1, 2, 3. What this means is I am taking 1/2 times f to the negative x. So instead of using -3, I now use +3. So 2 to the third, which gives me 4. Right. I'm using this because that's my f of x. So this is f of negative x. So instead of using -3, I now use +3.
Oh, double negative.
That's 4. Because we'd use the negative right here. That's why. So then I do the exact same thing, but -2 now becomes +2. This gets me 2.
So when x is a negative, it turns into a positive.
Right, when it was,
That's all x is positive.
no, that was just because it was f of negative x. If this was f of x, it would just be the -3, -2, -1. This one's going to be 1. Are you sure? F of. Okay. At 0, it's half. Because 2 to the 0 is 1 times 1/2. So that's 1/2, 1/4, 1/8, 1/16. Which in my chart, 4 to 1.5, 0.25, there you go. Calculator puts them as decimals, not as fractions. Yeah, you can use the calculator. Compound interest formula.
Every other word out of your mouth is formula.
A of t equals p times the quantity of 1 plus r divided by n to the nt power.
Right.
It's like the other one we just had.
Right, it's just like the other one. This is compound interest. There's two different types of interest. There's simple interest and compound interest. It's not plus or minus. Because if we're talking about, we use this in money a lot.
It's always
The basic one is I equals PRT. That will tell you just basic interest, how much you make. Like if I said you're going to put $100 in the bank for a year and you get 6% interest. How much do you get in interest? $6. But what compound interest is saying is that $6 is getting put back into the problem. So for year 2, how much money is in there?
another $6.
There's $106 in there. Then do another extra 6%. Take that money, put it back in. P is the principal original amount. R is the annual interest rate. N is the number of times the interest is compounded per year. Sometimes you hear things, it's compounded quarterly. What does quarterly mean? Every 3 months. T is the amount of time in years. You invest $250 of your money right now at a rate of 5.5% per year, which is really good percent. How much do you have when you graduate high school? How about when you graduate a 4-year college? Or when you are 30 years old? How long is it pretty much for everyone in here to graduate high school?
4 years.
Well, for you, it's going to be 2 more years. Okay? For the most part. I know everyone's at a different... Okay? No, most are 2. Now, in college, how long is it going to take you to graduate college? Well, 4 years, so it's going to be 6 years till you graduate college. On average, how old are you, or how many years is it going to be until you're 30? 14. It's not everyone. It's 14, 15, 13. I'll just take the middle.
14 and a half.
Now, this is compounded yearly. So I have A equals P times 1 plus R over N to the N T. What? Okay, A of T. It's so A of 2. How much do I start off with? 250. 1 plus, actually I can just write 1 plus, what's my rate? 5.5%, so how do I write it? 0.055. Now it's actually divided by 1. Why is it divided by 1?
Per year.
N stands for how many times per year. And this is only happening yearly. So it's technically 1 times 2. Because it's 2 years. For high school, it's 2 years.
So you're gonna have to do it over and put it in 6.
We'll do it again for T is your time. So 250, 1.055. You could do 1, but you're going to get a different answer from us. I just put 1.055 because it's 1 plus that to the second power, because 1 times 2. So in 2 years, you will have $278.26. That's only on $250. The more you put in, the more you return you get. The longer it stays in there, the more money you make. So let's see after college. So it's 250, 1.055. Now it's a 6. Instead of having to retype everything, what can I do? Second, enter.
You know the number that's after the A for the first one?
Uh-huh.
That's always going to be the same as the one at the end?
Now my time is 6 for 6 years. So after 6 years, you will have $344.71. Right here. 1 plus 0.055. I just added together.
So if it was divided by 2, would that?
We would take it divided by 2, yeah. It'd be different. It would be this number divided by 2. A of 14. So once you turn 30, 250. I put in 30. Or not 30, sorry. 14, I messed up. All right. Second, enter, change this to a 14. So if I didn't touch this money at all, I just left it in there. When I turn 30, there is now, no, it's still more than what you had before. That is correct. But that's leaving money in there. You're not touching it. You only started with 250. I know it's only 14 years.
You might put more money in there anyway.
Right. Let's say, I got to see what my next example is.
Is this real?